What's up, gang? So today we're gonna talk about thermal stability, very fundamental, as in mains, advanced as well as bit set. All covered ammonia carbonate. I'm going to cover everything: halogen, salt, sulfate, organic, everything. Theory plus question, very important. So for metal carbonate, alkali carbonate, you guys know it, very basic. The first group, alkaline, and p block carbonate, transition metal carbonate, and passive metal carbonate. You guys know what passive metal is, the which do not react very easily. That's it. Now let's talk about G1 carbonates, Fajan rule. I have already made a video on Fajan rule, but I will still explain it a little bit. Very stable, Na2C, no effect, and very fundamental, man. What should I explain? So let me go through this. Fajan character increases, which means covalent character increases. If covalent character is increasing, which means ionic character is decreasing. And we know that ionic is very strong compared to covalent, as ionic is electrostatic force. So when ionic character decrease, it becomes unstable. So we need to minimize Fajan rule. The opposite of Fajan need to be done here. So here NaMgAl, the size is increasing this way and the charge is increasing this way. So what is the Fajan order? The Fajan order will be aluminium greater Na, as aluminium, oh my god, what was I talking about? Aluminium has more charge and a greater size, a lesser size. What the hell am I saying, man? So the Fajan character or covalent character of aluminium is greater than sodium. Sodium is very ionic. So yeah, ionic, strong, stable. That's why Na is stable. Sodium carbonate is stable than aluminium carbonate. You guys can see this also here: Li2CO3, Na2CO3, K2CO3, Rb2CO3, Q1. Very small. It is very small, which means it is a bit covalent. It is covalent, so means ionic character is minimized. Ionic character is minimized, so means it is unstable. So yeah, lithium carbonate, when we heat, it becomes Li2O plus CO2. Rubidium does not. Group 2 carbonate, BeCO3, MgCO3, CaCO3, that's same. We just need to apply Fajan rule everywhere. Now let's talk about this BeCO3. When heated, becomes BeO plus CO2. At 800 degrees centigrade, CaOCO3. At 1200 secreted, it just need enough energy. अगर तुम इसको बहुत गर्म कर दोगे तो ऑब्वियसली वो क्या बोलता है, डिग्रेड हो ही जाएगा. Now let's talk about P block carbonates. Same Fajan, that's it, easy to break. Sulfide, PbCO3, when heated, PbO plus CO2, and Al2CO3 whole thrice, Al2O3 plus CO2, the salt oxide banana, that's it. Transition metal, pseudo inert configuration. We have discussed this in Fajan rule, very fundamental topic, that whichever element has pseudo inert configuration, 3d10, 4d10, 5d10, max polarization, it is most polarized, which means if it is polarized, the electron cloud density is moving towards it, so which means the covalent character is increased, so ionic character decrease. So polarization order is pseudo greater than non-inert than inert. So ZnCO3 easily breaks down into ZnO plus CO2, as these are pseudo. They are really polarized, which means they are high in Fajan order. Now let's talk about passive metal, HAPA. That's the trick, HAPA. Hg, H, A is Ag, and P is platinum, A is gold, HAPA. So when we heat it up, it becomes metal oxide. Then we continuously heat it, becomes metal. So HgCO3 heated becomes HgO plus CO2. When again heated, Hg plus O2, similar for all the HAPA. Now let's talk about bicarbonates. Bicarbonate, group 1, least stable. The same trend, same. We have to apply Fajan, that's it. And when we heat a bicarbonate, Na2CO3, the salt is released, as well as H2O plus CO2, that's it. Na2CO3, and further it does not decompose. If we had taken LiHCO3, then Li2O3 will have decomposed again to form LiO plus CO2. And same like here, same when MgHCO3 heated, MgCO3 plus H2O CO2, then again heated MgO, H2O CO2, that's it. P block, AlHCO3 whole rise, Al2O3 plus H2O plus CO2, and passive AgHCO3 becomes metal. Same as that, you need to remember that passive will become metal at the end. So directly metal, that's it. Now let's talk about sulfates. So basically group 1 sulfates, Na2SO4, when heated becomes Na2O plus SO3. SO3 gas is released and the stability order is this. Same, we have to apply a Fajan rule, that's it. Now, when second group 2, alkaline metals are heated, BeSO4, temperature less than 800 degrees centigrade, there are two special things happening here. When temperature is less than 800 degrees centigrade, it becomes BeO plus SO3. When temperature is greater than 800 degrees centigrade, then SO3 breaks down again. So BeO plus SO2 plus O2. SO3 breaks down into SO2 and O2. Same for this one, and yeah. Another thing I will like to talk about is, no, I'm going to discuss this later. First, no, actually, this is the one. So yeah, two acidic gases. There is only one single sulfate which, when heated, release two acidic gases, SO3 and SO2, both of them. That is iron sulfate. When iron sulfate is heated, it becomes Fe2O3 plus SO2 plus O2 plus SO3. Very important, asked many times, even in JEE advanced it has been asked. Now let's talk about nitrates. NaNO3 when heated becomes NaNO2 plus half O2. Pretty simple. When heated into 1200 degrees centigrade to 1400 degrees centigrade, Na2O plus N2O2. Drastic condition, like very very high temperature. It is almost 1300 degrees centigrade, very high temperature. So NaNO2 becomes Na2O plus N2 plus O2. This is the same Fajan stuff we have already done. And group 2 releases NO2. This release N2 and O2. Group 2, the alkaline, releases NO2. So when MgNO3 whole twice is heated, it makes MgO plus NO2 plus O2. And yeah, that's it. And same Fajan order for this. Now transition nitrate, transition metal, very important. Cracking sound, when heated they make cracking sound, and when ZnNO3 whole twice is heated, becomes ZnO plus NO2 plus O2. Same like here. Passive metal, HAPA, the metal will form its oxide, NO2 O2, and when oxide is heated, it becomes metal. Finally, once again, the HAPA speciality. Let's talk about ammonium salt now. NH4Cl when heated becomes NH3 ammonia plus HCl. No residues are left in ammonium salt heating. When NH4 whole twice SCO3 is heated, it becomes NH3 ammonia plus CO2, NH4NO2, H2O and N2. Whenever we are heating, we will try to remove the H2O. I have already discussed heating of ammonia salt. This is the second video on it. NH4NO3 heating N2O plus H2O. Won't go through it again. Organic heating, we will try to make CaCO3 calcium carbonate when heating it, the calcium salt. So yeah, this is an organic reaction, by the way. Now some characteristic properties which will help you guys to solve question. The color of compound. See, sodium when heated has a golden yellow color. Calcium, rubidium, cesium has a violet color. No, potassium actually. Potassium, rubidium, cesium when heated has a violet color. Calcium when heated has a brick red color. Barium when heated has an apple green color. Very very important. Barium when heated apple green. Lithium and strontium when heated has a crimson red color. It is all salt analysis, by the way. Chromium plus 3 and Fe2 plus when heated has a green color. Copper 2 plus blue color. Manganate 2 plus, manganese 2 plus has pink color. Iron plus 3 has a brown color. FeCl3 is a yellow. That's an exclusive. And NaCl, Ki, BaNO3 whole twice, PbNO3 whole twice, cracking sound when heating. And salt which melt on heating, जो पिघल जाते हैं. Group 1 carbonate and sulfides melt on heating. AgHg, Pb is chloride, AgCl, Hg2Cl2, PbCl2, they melt while heating. Now let's talk about although Zn2 plus when heated becomes yellow, when cooled becomes white. Copper 2 plus when heated becomes white or colorless, when cooled it becomes blue. Pb, Sn, Bi, lead and bismuth, pretty niche stuff. When heated becomes yellow, when cooled become browns. Cadmium 2 plus when heated becomes red, when cooled becomes brown. Yeah, I know it's hard to remember, but that's what we got to do. Famous gases, turns lime water milky. CO2 test and SO2, both of them. And CO2 plus K2Cr2O7, it remains orange. Initially it was orange and finally it is orange. But when SO2 is present, it becomes green. It turns potassium chromate into orange to green color, SO2. Now let's talk about ammonia. Dissolves in H2O, red litmus blue, gives dense white fume. Like if I dip this in HCl and make it come close to NH3, it will make dense white fumes of NH4Cl. NH4Cl. Now this compound absorbs oxygen. What was its name? I forgot actually. I have written it somewhere like here. These are the questions, by the way. Very, very important question. Pyrogallic acid. So pyragol, it absorbs O2, and H2O gas test is condenses at room temperature, makes copper sulfate anhydride into CuSO4.5H2O, which is blue in color. Ozone, tailing of mercury, it is metallurgy stuff, absorbs in turpentine oil, and KOH plus O3 KO3 yellow liquid. These are some questions. I'm going to write it down and discuss it.